Hi, in this video we are going to talk about priority queues abstract data types. So let's get started. What are priority queues? Basically, priority queue is an abstract data type such as stacks or queues. But every item has an additional property, the so-called priority value. We have already been discussing that what's the difference between abstract data types and data structures. The abstract data types are just the specification, basically just simple interfaces defining the concrete behavior. For stacks, we have the pop and the push and the peek operations, but we know nothing about how it's going to be implemented. We usually implement stacks with the help of one-dimensional arrays, but we are able to implement it with the help of linked lists. So arrays and linked lists are the concrete implementation, so they are the data structures, but the stack and the queue are the abstract data types. And this is the same for heaps. We have the underlying data structure as a one-dimensional array usually. We could use a linked list as well, but we usually use one-dimensional arrays. And we have the abstract data type, the so-called specification that's going to define the behavior, and this is the so-called priority queue. Okay, so we have an additional property, the so-called priority value, and in a priority queue, an element with high priority is served before an element with lower priority. So this priority is going to be very important. Priority queues are usually implemented with the help of heaps, but it can be implemented with self-balancing trees as well. It's very important that you may pose the question that, okay, heaps are not data structures as well, because heaps are implemented with the help of one-dimensional arrays, so basically heap is just another abstract data type, but usually we call heap a data structure as well as an abstract data type. It is quite misleading, but we usually refer to heaps as data structures. So that's why we could say that priority queues are usually implemented with heaps. We are going to implement priority queues with the help of heaps as well. Okay, but as I said earlier, it can be implemented with self-balancing trees as well. So it's very similar to queues with some modification. When we would like to get the next item, then the highest priority item is retrieved first. So there is no FIFO structure, so the first item we have inserted is not going to be necessarily the first item we take out. Okay, so that's what's very important, that is very similar to a queue, but we have a so-called priority value, and we are going to decide what items to take out according to this priority value. So the highest priority element is retrieved first. Okay, so again we have an abstract data type, which is just the specification or the interface, and we have the data structures, the concrete implementations. So let's suppose the fact that we have a one-dimensional array of integers 100, 19, 36, 17, 3, and 25. This is what we have been discussing, that we have to assign another value, the so-called priority value, to every single item. So for the 100 we have the priority 2, then the priority 1, 6, 5 and so on. And whenever we would like to take out an item from this one-dimensional array, we are going to take out the one that has the highest priority. This is why we assign these priority numbers, because we are able to decide what's going to be the next item we take out according to these priority values. What's going to be the next item? It's going to be the 17, because 5 has the highest priority if we exclude the 6, because we have already considered the item with priority 6. It's very similar to queue, but instead of the FIFO, so first in, first out structure, the first item we have inserted is not going to be necessarily the first item we take out, because we are going to make the decision according to the priority values. Okay, of course we are able to insert custom objects into a one-dimensional array, and again we have to assign some priority values for these person objects, and we are able to decide what person objects to take out of the one-dimensional array according to these integer priority values. So the higher the priority value, the greater the chance that we are going to take out the given object. Okay, in this case, the person 1 has the highest priority, so it's going to be served first. What about the operations? We are able to make some operations with the help of priority queues. We have the insert with priority method with the data, and of course we have to specify the priority. Sometimes we do not specify the priority, as we have discussed, for example for integers, because the value of the integer can define the priority as well. This method will insert new item into the priority queue. We have to specify the data we would like to insert and the priority associated with that given data. We have the getHighestPriorityElement method. It's going to return the element with highest priority. We have to reconstruct the heap every time we return an item because the structure of the priority queue or the heap has changed. Okay, for maximum heap returns the maximum element. For minimum heap it returns minimum element. We are going to talk about maximum heap and minimum heap. Basically heaps are going to be tree-like structures, and the root of this tree-like structure is going to be the item with maximum value for maximum heap. For minimum heap, the root node is going to be the item with the minimum value. What about the peak method? It's quite similar to what we have seen for stacks and queues. It returns the element with highest priority, but the structure of the heap does not change. So we just return the value without removing that given item. And it's very important that with the help of priority queues, we are able to sort some data. The concept of priority queues naturally suggests a sorting algorithm. We just have to insert all the elements to be sorted into a priority queue. Then we sequentially remove these items, and it will be the sorted order, of course. Why is it working? Because we have been discussing that priority queues rely heavily on priorities. If we take out items, the one with highest priority will be returned. So the result, a sequence of decreasing priorities. This is the sorted order. So for example, tree sort or heap sort rely heavily on these kinds of sorting method. Very important that we are going to see the concrete implementation of the heap sort, and we are going to have the priorities associated with every item. We are going to store integers, and because we store integers, we don't need any further information for the priority, because the value of the integer is going to determine the priority value as well. So greater the number, higher the priority. And this is exactly what we are looking for. We are looking for the item with the highest priority. The highest priority value for integers is going to be the greatest item. So this is why this priority queue is able to make the sorting operation. Thanks for watching.